Till our previous video, we saw what is job, status, and task. Then we saw how hitting up action create a job for us. We also discussed how transformation are stored inside job and what are tasks. We also discussed how in just reading a file, we can hit our two actions in simultaneous way. In continuation to that, next video. Hello to world, welcome back to another video. So in this video, we are going to discuss about joins, and in this Spark, basically there are three kinds of join. Okay, one is short merge join, one is shuffle hash join, and one is broadcast join. Till our previous video, how we have taken the approach. First, we always do a theoretical kind of thing, and then we shift into the practical. In the same way, we are going to do in this video as well. Okay, so our first priority will be the sort merge join. Okay, in sort merge join, I want to discuss you about the few components that will be very similar to the shuffle hash join as well. But once you get the idea behind the short merge join, it will be very easy. Okay, considering two tables, I have created two tables for you. Let's say this is my table 1. Okay, and this is my table 2. Table 2. Cool. Clear this point? So we will have different we will have different columns into these tables. That is table 1 and table 2. Correct? Out of that, I want to join these two tables using customer ID over here. Okay, and I have given you some sample customer ID. Table 1 is having 024 024 542 in table 2. Okay, so what's the very first point when you are going to do a shuffle hash join into it? Okay, so let's do this in phases. Okay, let's understand this in phase. So in phase 1, what will happen is this is going to bring everything into the same partition. Actually, these two are going to get shuffled. Table 1 over here and table 2 from here. Okay, these two both are going to get shuffled actually. Clear this operation. Clear this. They are going to get into the shuffle kind of a thing. Now, what will happen after in this shuffle? In this shuffle will try to bring both the IDs into the same partitions. Remember, let me draw one executor here. Clear this. Let's put this aside, and let's say this is my executor. Okay, and in my executor, as you are aware, I will have different partitions, right? Let's say this is my partition 1, and this is my second partition. Okay, sorry. This will be my second partition over here. Okay, these are two different partition. It might be possible, right? This ID, let me copy it. Control C, Control V. These customer ID are present over here. Clear this. And the customer ID from table 1 are present over the different partition. That is partitions 1. If these are two different partitions, this might be the possible, right? But we have the same executor. Same executor. Clear this. Same machine. Executor is what? Same machine, right? So we have different partition area. This is partition 1. I will write it as partition 1. This is my partition 2. So what's happened in this case is it is going to shuffle it. The operation is written over here. It is going to shuffle it. And what it will do, it will bring down both the IDs which are clear this into the same partition. Okay. After shuffle, what will be the resultant of this? Let's say let's go with the color coding. Okay. This is my partition 2. And let me draw the partition 1 as well over here. Okay. Partition 1. So as you see, 0 to 4 is present here and 2 and 4 is present here. After shuffle, what it is going to do, right? It will take the customer ID. It can bring it to any. There is no certain rule over it. Okay. It will bring, let's say, customer ID 0 to 4 here. Okay. It will remove the 0. 2 and 4 are common. And let's say 0 and 5, they didn't catch any match. So the ID will come here. The customer ID for these two will come over here. Clear this part? 0 and 5. 0 and 5. Clear this part? This understandable by you guys? I hope it is understandable. Now, after the shuffle, it has done this. But remember, this is an extra step it has done. Till now, partition 1 was having this, correct? Partition 1 was having this, and partition 2 was having this. So now it is going to join between these two. So see, same key has came into the same partition. Same key has came into the same partition. 4 and 2 are not present here. So now what it has done is that it has shared the exact same joining key end up into the same executor. This is my executor inside the same partition. Now what it is going to do, it is going to sort it. Okay, these are the operations basically which we are discussing. Now it is going to sort it, sort this as well, sort this as well. Okay, in partition, as we are aware, we can do the parallel processing, right? So it is doing parallelly. It is sorting this as well. It is sorting this as well. Okay, both are getting sorted. And once these are sorted, like 2, 4 is sorted here, now it will start matching it. 2 is matching to 2, matching key will be matched and will be sent to the output result. Same way go over here as well. Okay, so this is how our short merge join work. Basically 3 steps are there. Okay, remember that. First one is it is going to shuffle both the tables and it is going to bring the same key into the same partition. For that, it has to do shuffle. Why shuffle? Because same key in the same partition. After the shuffle has been completed, it is going to sort it for us. After the sorting process, partitions are sorted. Now it is going to match it at the end, like it is going to match this data, and what is coming as an output, it will bring it out. Okay, so this was the theory behind it. Now let's jump into the practical orientation for the same. Okay, so if I go to my Databricks, okay, and I will open my this partitioning. Okay, I have opened my partitioning over here, and this is the same notebook actually, learning one. Okay, and we have created the Databricks second as our Unity catalog. Let's close it for a moment and let's get a big screen out of here. And I want you to scroll completely down. Okay, we will make a new heading out of it first of all. So I want you guys to get over to my GitHub, but before that, let's make a heading. We are studying today join. Okay, so mark down for join. We have started with the join. Cool. We have done the joining. So let's put down the heading as a join, and I will mark it as heading 1. Okay, this is heading 1. I have marked. Control Enter. Cool. Now the SortMergeJoin, that is again marked down. I will %md, sorry, %md and SortMergeJoin. Okay, and I want you to head over to my GitHub over this repository, Databricks Talk. You will find one file here, join dataset. So I have created this join dataset for you guys. What it is doing, let me show you. Just copy the code from here. It is copied, bring it into the cell. Okay, what it is doing, it is creating a dummy dataset for us. That is, it will create an ID column with customer ID. Then we are going to create a full name, and we are concatenating it with customer underscore and the customer ID, which is generated over here. Okay, so it will generate customer 1, customer 2, customer 3, likewise. Same way go for email. I have concatenated that. So it is basically doing it in a loop kind of a thing. Okay, I hope you are getting the point. And for these cities, it is doing same way. It is creating 100 records for order as well. Okay, from 101 to 100 laptop monitor. Basically, we are trying to do a join here. Okay, so I am going to consider customer ID for my joining key. Okay, let me run it and show you the data frame first. Okay, let me run it. Cluster is getting up, and it has up, and the cell is started to run. Okay, by the time it is running, I want let me write the other code for you guys as well. So we will writing that joining statement for this, right? So it has completed. Let's see the result first. Basically 9 tasks are created. Now I believe you are very clear about the job, task and stages, right? So here is a sample data for us. Count has 100 records. Order data frame basically has 100 records, and these are the displayed 10. We have limited it to 10, so that's why only 10 records are being displayed. This is the limit we have put in. You can actually remove this and view the complete data frame. Okay, so this is how our data frame are looking like. And what is our task? We are going to join using this customer ID over here. You see the customer ID over here, data frame to this customer ID over here. Okay, so we are going to do that. And as you see, this is numerically sorted by default, but it is not. That's why the sorting is required. I hope it is making sense to you guys, right? Okay, so let's join it. So I will write as df underscore join as my data set. Okay, and I will write it as df customer, that is customer customer dot. I want to give it a hint. I just want to like Spark is very clever, it do optimization by its end. So I want it to use sort merge join. So I will say him, okay, I am giving you a hint, do a merge because both the data set are large, do a merge. By the way, 100 record data set is not large. It is just for our learning purpose. I want to join it over order. Okay. And over order, I want to join it over what? Like my key, basically. That is, we have already decided it will be customer ID. Okay. And how you want to join it? Basically, now coming to the SQL, we have different kind of join, right? Inner, left, right, full outer, and intersection join, and taking only the left table, removing the right table completely. So that kind of we have to specify here. I want to do inner join currently. Okay, inner. We are interested in inner join. Like we can either provide it as how you want to join. You want to join it as inner join. Okay. I believe it is very clear to you guys till now. Okay. So what we are doing here, we are joining the customer with the hint HI. It is hint here. HINT. We are merge and we are doing the joining of the data frame order on customer ID. How we are doing it is at is a inner. Let's do this, and I'm not going to display the join result for you because that is not the perspective of this video. The perspective of this video is to define how this strategy is actually working behind the scene, correct? We are interested in that, right? So it has executed. So as usual, what we are going to do, we are going to see the explain version of that. That is the plan which it has created for us. So df.join.explain, explain. It is going to, show me which all step it has taken to perform this join. And even if it has even created the shuffle hash join, which we are discussing so far till now, even if it has done that join for us or not. Okay, I'm not able to scroll it. So we read it from the bottom up approach, correct? We always do the same way. Let me zoom it a bit so it will be very clear for you guys as well. Okay, I hope the screen is very clear now. So I want you to, just ignore this. This is Photon explanation. Photon is not enabled right now in serverless cluster. That's why it is showing in this range. Okay, so the first thing it has done is like I want to come head over. It has taken multiple rows over here. It has done some shuffling over here. Let's remove that. We are interested in the sort merge join. Okay, so here is the line. Sort merge join was performed on customer ID, and it has casted the customer ID as a big int, and it has done it in a form of inner join. Okay, and what kind of join it has done? It has done it on a customer with the full name, email ID, city, created, order ID, product, amount, and order date with the help of customer ID. Okay, this was done, and adapted. We will discuss about this adapted SQL plan. Actually, this plan is not completed. So this is how it is doing the sort merge join. As we see over here, the join explain. It has taken our ID, how we have described it, and then it has performed the join. So 3 parts. Okay, that is since shuffle is coming. So again, it is an expensive join, but again, we do it in real world project as well because this is required. This is a required because you can't always go with optimization, right? Your data has to be in million or trillions of data, right? So every time you can't just optimize your joins. So sometimes it is very evident that you have to go with these kind of join as well. So with having said that, I will be closing our video for today over sort merge join. In the next video, we are going to discuss about a shuffle hash join, its theory and its practical impact, how it is going to work. And there is not much major difference between them. I will be modifying this step for you guys as well, and start creating the notes because this is the interview question as well. And even if you are appearing for a Databricks interview, Databricks associate certification basically. So this is a kind of a join which is basically asked from you. Okay, sort merge join, how it is performing. So you should be knowing the internal working of that. If you are joining the 2 tables, how it is going to do a shuffle of it. After the shuffle, what are the things happen in our partition level? These are the partitions are present over the executors. And after the executing has been done, how it is going to show you the data over here. Okay, and what are the intermediate steps it has performed in between, that is the sorting step. Okay, I hope the video was very clear to you guys. If you have any comment, please give me your thumbs up or comment in down the section, like what is the thing which you didn't get, and help me to improve so that we all grow as a team. Okay. Thank you for this video and see you in the next video.